So in this video, we are going to see about a problem on common emitter amplifier. So the given problem is for a common emitter amplifier, HI is equal to 1050 ohm and HR is equal to 2.5 into 10 power minus 4 and HFE is equal to 50 and H0D is equal to 25 micromho and Siemens and RS and RL, source resistance and load resistance is equal to 1K. Okay, and they are asking about what is current gain. Okay, so we know that the current gain A is equal to IL divided by IB. Okay, output current divided by input current. So IL I can write it as IL is equal to minus IC. So you can see the direction, it is opposite in direction. So minus IC divided by IB, where IC I can write it as IC is equal to according to the Kirchhoff's current law, the incoming current is equal to outgoing current. So IC is equal to, this IC is equal to HFE IB, this current, plus this admittance. The admittance, this is nothing but admittance. Admittance means I by V. So I by V, H0D is nothing but I by V. So the output voltage is nothing but VC. Okay, this is your VC. So here the IB get cancelled out and the voltage across this resistance is IL into RL. So I am going to substitute instead of IC, VC I am going to substitute IL RL. What is IL by IB? IL by IB is nothing but A. This minus will go inside and you can bring this whole term to this side. Okay, if I bring this whole term, I will get A is equal to minus HFE divided by 1 plus H0E RL. Okay, so if I substitute the value, I will get minus 50 divided by 1 plus 25 micro into 1K. That is nothing but minus A is equal to minus 48.78. This is approximately equal to minus 50, right? So I can write this A is nothing but minus HFE. Okay, so you can see the current gain value is nothing but minus of HFE. So next, let us discuss another problem on a Zener diode. So here they have given RS is equal to 220 ohm and this is your Zener diode and the VZ value is nothing but 18 volt and RL is equal to 200 ohm and this VS will changing from 20 to 30 volt and we need to find the value of IZ minimum and IZ maximum and they have asked about P minimum, PZ minimum and PZ maximum. Okay, so here since it is parallel, this the voltage across this one is voltage across this one. So IL. So this is your IL. So IL is equal to 18 divided by 200. So what is 18 divided by 200? 18 divided by 200 is 0.09. amps. Okay, so this is your IZ and this is your I. Okay, so if 20 minus 18 divide by 20 minus 18 divide by 20, you will get I, right? So what is the value of I? 2 divided by 20, that is 1 divided by 10, that is 0.1 amps. So if I is equal to 30 minus 18 divided by 20, you will get 12 divided by 20, that is 6 divided by 10. 6 divided by 10 is 0.6. 0.6 amps. So we know that I is equal to IL plus IZ. So what is the value of IZ? IZ is equal to I minus IL. Okay. So if I substitute IL value 0.1 minus 0.09. So you will get 0.01. Okay. So if I substitute 0.6 minus 0.09, you will get 0.5 needed. .5. So this is your I minimum, and I is at maximum is 0.51. Okay, so we need to find the value of PZ maximum. So PZ maximum is VZ into IZ maximum. So that is nothing but 18 into 0.51. That is nothing but 9.18. So if I want to find the value of P is at minimum, V is at into I is at minimum. That is nothing but 18 into 0.01. That is nothing but 0.18 watts. So we will discuss another problem on our Zener diode. So this is 16 volt and this is 1K. And here you have a Zener diode, and here you have 1.2K. This is your load resistance, and this is voltage across this one is 10 volt, right? This is 10 volt, and P is at maximum. P is at maximum is 30 milliwatts. Okay. So they have asked what is the value of VL, that is a voltage across this resistance VL, and VR, this one VR. Okay, and what is the value of IZ and PZ? Okay, so first condition. Okay, the first condition what we have to do is we have to open circuit this this Zener diode. So if I open circuit this Zener diode, the voltage across this one is VL, right? So what is the voltage across this one? VL is equal to 1.2K into 16 divided by 1K plus 1.2K. So this is nothing but 8.73. So the voltage across the load is 8.73, and V is at we already know that is 10 volt. So the VL is less than VZ. So VL is less than VZ. So the Zener diode is off. Okay. So Zener diode is off. So if that is the case, if I plot the values with respect to IZ and VZ, okay, so I will get this value as VL as 8.73, this point, and after that it goes to goes in this direction, okay. And so I have find out this the voltage across this one is 8.73. Therefore, if I subtract in order to find the value of VR is nothing but 16 minus 8.73. So 16 minus 8.73 is 7.27, right? So what is the value of IZ? IZ is 0 since it is open circuited, okay. So if IZ is 0, what is PZ? PZ is equal to IZ into VZ, that is equal to 0. Okay. So the next condition. So next condition is I'm going to replace this RL if RL is replaced by 3K, okay. So if RL is replaced by 3K means again, if I do the same calculation, what is this is 3K now, okay. So what is VL? VL is equal to 3K into 16 divided by 1K plus 3K. So that is nothing but 3K into 16 divided by 4K. So that is nothing but 12 volt. Okay. So here you can see this is a voltage across now this is a voltage across Zener diode and the load. Okay. So now the VL is greater than VZ, right? So the VL is greater than VZ. Therefore the Zener diode is on. Okay. So if the Zener diode is on means what I'm going to do, I'm going to replace the entire circuit. Okay. I'm going to replace the entire circuit by. So here instead of open circuit, since the Zener diode is on, I'm going to replace it by a 10 volt, and this is this is 3K, right? This is 3K. So what is the voltage across this one? Voltage across this one is VR is equal to 16 minus 10, that is 6 volt, and voltage across VL, that is this one is 10 volt, and what is the IL value? IL value is 10 divided by 3K, that is nothing but 3.3K, 3.3 milliamps, and now I need to find the value of IR. IR is nothing but 6 divided by 1K, that is nothing but 6 milliamps. So we know that IR is equal to IL plus IZ, right? IZ. This is your IR, and this is your IZ, and this is your IL. So what is the value of IZ now? IZ is equal to IR minus IL. So 6 minus 3.333 milliamps. That is nothing but 2.67. Okay. This is your IZ. Okay, so if the IZ values, this means what is PZ? PZ is equal to IZ into VZ. That is 2.67 milliamps into 10. That is nothing but 26.7 milliwatts. This is your PZ. So they have already given the PZ value as 30 milliwatt. That is not exceeding this values. Okay, so you can see when This is your IZ and this is your VZ, and when it is turned on, it is look like this. When it is turned off, it is look like this, and this value is nothing but 8.73 during this time. So during this second case, it is 2.67 milliamps. It is in milliamps, and